big crowd. Thanks for joining me, because there's also a Josh Long talk going on, right? So just in case you missed it, you can still go there. But thanks for coming to my talk. I hope you had a great lunch. I really liked the shrimp pasta. It was pretty special. But I'm not going to talk about that, obviously. I'm going to talk about cutting-edge continuous delivery, automated Canary Analysis through Spinnaker. Now, that's quite a mouthful, right? Let me first introduce myself. I am Andreas. I'm a solution architect at Pivotal, and I am active in the application transformation, or AppTX, unit within Pivotal for EMEA. I used to work for JBox, and there's a couple of ex-colleagues here, which is pretty cool. And you can reach me on Twitter, of course, with my Twitter handle, Andreas. Also, after the talk, if you have any questions that you didn't get an answer on, you can always just contact me there. Right. So, when we talk about continuous delivery, the ultimate goal that we try to achieve is to deploy software quickly and automatically, right? And this can only be achieved if we're able to push new code without fear, right? And that's something which I've seen throughout the years, even before I started doing software development. There's this kind of, these two opposing forces that try to battle it out. On the one hand, you've got speed, and on the other hand, you've got confidence. And they don't always work together well. Maybe like back in the days when we first started software development, or at least I started for software development, some people used to just change things in production without testing them, just hot swap code, perhaps, that gives you a lot of speed, but that doesn't give you any confidence, right? So then we started adding manual tests, but manual tests were expensive, so we started grouping features, and that led to corporate release cycles. And those things had a huge impact on speed again. So while we had increased our confidence, we had lacked some speed. So then we started automating these tests, right? And that gave us some kind of an extra boost in speed, but that wasn't enough. What we saw throughout the recent years is that we moved towards architectural modularity, for instance, microservices, so that we could go to production faster, right? These microservices are independently deployable units that can go to production without having to have this huge release cycle. So that gives us an extra speed, right? Because you can work in parallel, you can have multiple different teams working on multiple different services. But that doesn't really work for our confidence pretty well, right? Because now we can't really have an acceptance environment with all our microservices. You could do that, right? It's possible, but that gives you this, this coupling again. So you have to go all together to production. Like just if you have an environment spun up on acceptance, just to test everything with the certain versions that are currently in production, the moment you've run your tests, production probably has changed already, right? Because that's the nature of microservices. So we had to look at other alternatives. And for one option is consumer-driven contract tests. I don't know, anyone heard about that? Right? So there's Spring-type contract, right? There's a talk about that tomorrow, I think, in the morning. So that's really has a lot of value. It allows you to test your interactions independently without having this huge environment where everything is deployed on together. But it doesn't really test behavior. It only tests whether your syntax is correct, whether you're contractually sending the right thing and receiving the right thing. Right? So it doesn't really test whether the behavior of your service is working well together with all the other services, and whether the data in your databases is actually working well with each other. Right? So that gives us still a problem for our confidence. So you see with microservices, you have a lot of speed, but you still don't have a lot of confidence, or at least you have limited confidence. And then we got to look at alternatives, right? And one of these alternatives we're going to be talking about today, which is called automated Canary Analysis, right? So I will talk about that a lot, but know that this is kind of something that has been talked about a lot in the past, or at least Canary releasing has been talked about, but I've not really found an easy way to apply it without having a PhD in mathematics or something, right? So that's kind of what Spinnaker will bring to the table. So let me first introduce Spinnaker, right? Spinnaker is a multi-cloud, multi-region deployment tool, originally built by Netflix, and it supports a lot of different clouds, right? A lot of different abstractions, one of which is Kubernetes. So like even any cloud that hosts Kubernetes for you will also work with Spinnaker. Cloud Foundry as well, to all the different distributions, including Pivotal Cloud Foundry. And of course also IaaS, so also the major cloud providers like Azure, Amazon Web Services, even bare metal, OpenStack, DCOS is supported as well if you are using Oracle Cloud. And on Google, since Google has heavily invested in this project, they also support App Engine and, of course, Compute Engine. Right? So there's a lot of clouds that are actually plugging into Spinnaker. Right? So that's pretty interesting. So you might wonder, like, why am I talking about Spinnaker here on Spring I/O, right? Because this is a Spring conference. Well, the Spring team, and specifically Spring Cloud, already had something for continuous delivery. They have this thing called Spring Cloud Pipelines, which has been recently rebranded to Cloud Pipelines, because actually that project has nothing to do with Spring. It's just a way to have continuous delivery set up in an easy way, a paved road, where you can have some kind of a pipeline out of the box with a number of steps, either in Jenkins or in Concourse. So that's already there. You can already use that. It's been rebranded to Cloud Pipelines, and it has been given to the community. Why actually do we now refocus with Spring Cloud? Do we refocus to Spinnaker? Well, the reason is here state. Now, where do you store the state of your cloud while you're actually doing your continuous delivery? Where do you get your information about what's currently out there? Well, Cloud Pipelines used to use, or it actually uses tags on Git. Right? So in Git, you can tag, if something's deployed in a certain environment, you can tag that commit, right? So that's pretty straightforward. However, it's also limited, right? So what if you do manual deployments and you don't go to the pipeline? Then your whole tagging system is kind of, you don't have a lot of confidence in it anymore, because it might not resemble what's currently in production. Also, if you have different live versions across different regions, across different accounts and different clouds, then that's pretty hard to keep track in a Git repository. And if you want to do sophisticated rollbacks, if there's, for instance, multiple versions on production at the same time and you want to roll back to a specific one, now that gets really difficult with just tagging. So Jenkins and Concourse, where Spring Cloud Pipelines or Cloud Pipelines relies on, don't offer the idea of an inventory, of some kind of a repository that keeps track of what's currently, where your application is currently living, right? And that's different with Spinnaker. So Spinnaker gives you the inventory across all your different regions, all your different clouds, and all your different accounts. And it combines that knowledge with pipelines that can do really sophisticated stuff, much more sophisticated than your Jenkins or your Concourse could ever do. And we're going to see a demo today about what that could be. All right, so let's first look a little bit under the hood, right? So Spinnaker under the hood looks surprisingly familiar, right? It's just a microservice architecture, if you can call it that at least, of Spring Boot applications, right? So if you're ever having to troubleshoot anything, this is going to be super easy for you, because this is just your regular Spring Boot applications. There's one in particular which is interesting, is Halyard. It's like a bill of materials for these different microservices. So these different microservices have different versions, and they kind of work together with certain versions work with certain other versions, right? And Halyard makes sure that everything is set correctly, a little bit like your BOM in Spring Cloud dependencies or Spring Boot dependencies, right? So it kind of does that as well as a service. It also helps you spin everything up. So that's kind of how it looks like under the hood. It also has an Angular UI, by the way. But enough about that. Although I have to say, since Netflix built this, Netflix started out with another solution that they've built first, which was called Asgard, and they have replaced that with Spinnaker and taken all their learnings from Asgard and applied it here. And for this Spinnaker version, they started using Spring Boot. And you might remember Netflix OSS being used in Spring Cloud. This kind of makes it full circle, because now Netflix is also using Spring to build their own applications, right? They've been doing that for like half a year already. So that was pretty big news as well. Aside from Netflix, who have obviously been contributing the most to this application, this platform, Google has been heavily invested in this as well. If I'm not mistaken, they've actually put 14 FTEs on it just to be building Kubernetes support and even much more features. Even the like support for App Engine, for instance, is also in there. So aside from Google, Microsoft has contributed to the Azure support and Pivotal, the Cloud Foundry support. So this is actually an entire ecosystem. And if you look at it, right now it kind of supports all the major clouds, and there's actually more clouds coming. So we're going to be using Azure for our demo, but it also perfectly works on Google. The CI system integration, it really wants to integrate with CIs because it doesn't want to do builds, right? If you have your Jenkins or your Concourse or whatever you're using for CI, then keep using that because that's specialized in continuous integration in building your software. Spinnaker doesn't care about that much. It can bake images, sure, but it's not really focused on it. It's focused on having these strategic deployment pipelines for taking your application that's built and then putting it in the cloud. So we're going to be using Travis in our case here for our CI. Monitoring, we're going to be using Datadog for metrics because we're going to need metrics for this automated Canary analysis. Notifications, you can send out notifications, of course, and you can have artifact support, which is kind of just a repository where you get your released deliverable from, right? So this could be Docker, it could be just an HTTP call or S3. In our case, we're going to be using S3 on Amazon. So we're going to be using a couple different services on different clouds, right? And there's no problem in doing that. So the Spinnaker platform has been contributed to the Continuous Delivery Foundation, which is a new foundation underneath the Linux Foundation. So now it's completely part of the Linux Foundation, which is also pretty interesting. So let me talk a bit about what Spinnaker can do, right? Because I've been talking about what Spinnaker is, but not necessarily why it's interesting to us, right? What are these new cutting edge features, right? So when we go to the cloud, what do we care about? And basically, when I go to teams and I look at how they work, they mostly have issues when they want to scale out to different clouds or to different regions. So cloud deployments in general are pretty complex. Right? If you start simple, then it's okay. But once you start having multiple people and multiple teams pushing multiple changes over multiple different services to multiple availability zones, multiple regions across different providers, then this stuff becomes more complex. This becomes difficult because you gotta know all your different abstractions and all the different concepts of all the different clouds. And most companies are focused on one provider that I know of, like they choose Azure or Google or Amazon, right? But I don't think there's many companies that completely migrate to the cloud, right? There's also something running on-premise. Now, it would be kind of annoying to have your applications running on-premise and in the cloud and not have a composite view across all these different environments, right? Especially if you have dev, acceptance, integration, or whatever you call it, and production, right? Even if you just use Amazon, right? If you have a production Amazon and a development Amazon, they're probably different accounts, right? So if you want to get a view of where's your application, you're going to have to log into the production account to see it, right? Or at least that's of my knowledge. So that's quite annoying. And Spinnaker offers this multi-foundation, multi-cloud, multi-region view of your application. Just gives you in one page, where's your application? Where does it live? How many instances? Is it alive or not? Is it having issues or not? And that's pretty helpful if you're just a development team that wants to see what's going on, right? Aside from this, so this is the inventory that we talked about before, right? Aside from this, teams want to get an easy solution to go to the cloud, right? They want to have a paved road in the wilderness, in the chaos of cloud, right? So an easy pipeline that's maybe even pre-built as a template, that really helps teams to go to the cloud easily. So that's also what Spinnaker offers us. It's easy for teams to onboard on this because it abstracts away all the complexities of the clouds themselves. Right? It gives you this easy path. Also, once you're actually in production, you want to be able to roll back quickly. Right? So easy rollbacks are important, right? Because you can have as much speed as you want, right? But even though you might have a lot of confidence, things might still go wrong. And then you want to go back in an easy way. So you want to be able to go back in time without having chaos, right? And Spinnaker offers you this with just one click of a button that you could roll back. Of course, if you have database migrations, you might want to have a rollback database script or something like that, right? But aside from that, it tells you exactly what it's going to do. And why is that important? It's because when we do rollbacks, this is not something that we want to do in a very this is not something that we're kind of happy about, right? This is mostly a stressful situation, right? We're mostly under stress if we do rollbacks. So that's when we make mistakes. And just making sure that we have a scripted way, or like a provided way from Spinnaker that tells you exactly the steps that it's going to do is really a big help. So I'm not going to demo that, but it's just a click of a button, and you can go back to any versions that you still have supported. Now, who knows this picture? Anyone from the crowd? So a couple, and what is it? Like, when do you see this? GitHub is down? Yeah, exactly, right? And there's normally not many people. I think just here is the most amount of people I actually ever gotten in the talk. So the idea is that GitHub wants to make this sound like it's impossible, that it's never happening, right? Because unicorns don't exist. So when GitHub is down, we want to make sure that the blast radius is as small as possible, that as least amount of people are impacted as possible. So when you deploy, you need to make sure you deploy during a time frame when there's not many people online, there's not a lot of traffic, and also that you can easily remediate when this actually goes down. So having deployment windows and keeping track of when your traffic is coming in is important for identifying these. And you can even link that with when people are actually in the office, right? Because you might do this at night, but then people are on call, and it's not really the same experience as when you're actually in the office. So Netflix has actually integrated the traffic of their application that they're currently deploying, which could be different for each application, and then link that to their deployment window. So the idea is that you would prepare everything up front that is required for doing your deployment up until the point where you're actually going to switch the traffic, right? And at that point, you wait until you hit the deployment window, and then you roll forward, right? So having that as an automated solution is pretty powerful. Of course, when you deploy as well, you don't just want to, like bring everything down, bring everything up, right? Because you're going to have downtime. Even things like blue-green deployments might not be enough. Like here you see an example of a blue-green deployment. Netflix called it red black, which is pretty funny because their logo used to be red and black, but now it's red and white anyway. So jokes on them, I suppose. Blue-green brings up the next version next to the first version, right? So you have version 1, version 2, both ready to serve, right? And version 1 is just getting all the traffic. The load balancer on top of it can easily switch just to this version 2 and then have all the traffic routed to version 2. If there's any issue, version 1 is still running, you can just flip the switch in the load balancer and you'd have all traffic routed to version 1. So you wouldn't have that. It would be an easy rollback, yeah? So it's not really something that would be difficult to remediate. However, you would have all your users exposed to this downtime or to this issue, right, that you would have with version 2. You can fix that by doing rolling blue-green or rolling red-black in this case, where you wouldn't have a full switchover, but you would have it gradually by bringing an instance up at a time and an instance down of the previous version at a time. Or you could do some sophisticated load balancing, which routes a portion of the traffic, right? With each step that you take, you would either do a manual verification step, a validation, whether this would work or not, or you would have some kind of a smoke test or something. Normally, this doesn't go really deep, or it's not really a sophisticated test. Now, Canary testing takes it one step further. And the difference with rolling blue-green is that it has this automated Canary analysis in between each step. Right? So when you're routing traffic to more and more users, you're going to check whether the new version acts the same as the previous version, or even better, right? And if that's the case, you're going to scale up. If it's acting worse, it's going to scale down, right? It's going to roll back. So that's kind of the idea here. And the way it's doing it is looking at metrics. These could be system metrics, of course, but it could also be business metrics. So you could have, for instance, if you have an e-commerce website, you could be selling shoes, for instance, right? If all of a sudden shoes are not being sold anymore, right, then you might have an issue with your website, with your deployment, right? And then you can actually have that as a metric that you want to take into account, right? So just looking at the difference in whatever portion of your user base has access to the new version can give you this information to roll out or to roll back, right? That's the idea. And we're going to be actually doing this in our demo. So automation is key here. You can't do this manually, right? And Spinnaker kind of tries to automate all this stuff for you. Like when you automate continuous deployments or continuous delivery pipelines, then normally what you do is in Jenkins, for instance, who's using Jenkins? Who's not using Jenkins? All right, oh, it's still a fair amount. So most people are using Jenkins, right? So you write these scripts, right? You write the Groovy scripts that will do this stuff. These scripts could be using libraries, right, which could be tested separately. But mostly, when people actually write this stuff, the moment they're testing it is when they're running the pipeline, right? So this is not really something which is super robust, right? It's kind of trial and error a lot of the times. So having something which is built in a platform for you with these blocks that you can compose that are tested by the community and improved by the community is much more powerful, right? Because I think of all the people who are doing these Jenkins scripts, a lot of us are just doing the same work. We're just writing the same scripts, right? We're just doing it all over and over again. So having this as part of the platform is a real benefit. So here you have one of the examples. One possible pipeline you could want, which is a deployment to production one. So it looks in the test environment. It finds the image from the test environment, and it uses that to deploy a Canary. This is the new version, right? So it deploys the Canary. Then it's waiting 30 minutes because it wants to get some metrics first from the people who are exposed to the Canary. And then eventually, if the Canary works fine, then you can have a manual cutover. So you can have a manual approval button that you say, okay, this feels good for us. And this is also going to be in our demo. And then once the Canary is verified, then you can have a blue-green deployment to production because you don't want any downtime, right? And you might want to have this rolling if you really want to. And then eventually, if this is deployed, you want to tear down the Canary after 2 hours, right? Well, you tear down the Canary, and you wait 2 hours, and then you destroy production, right? So Canary you can just get rid of right away. So this is a possible pipeline that you could build. Now, all of these steps are provided by Spinnaker. And let's just look into the blue-green one, right? What is entails? So Spinnaker does all this stuff. So a blue-green deployment step or a stage for Spinnaker does a lot of steps which have a lot of tasks and a lot of operations. So in this case, it does like a deploy and default, and then it's shrinking the cluster, the previous cluster, disabling it and scaling down. And the disable of the cluster actually determines the help provider, disabling the cluster itself, monitoring it, forcing the cache refresh, waiting for the disable, and then forcing it again. And then the disable of the cluster has a couple of operations which are low-level operations, right? So it's changing the forwarding rules, the target pools, and it's removing the actual instance. So all this stuff is being done for you. Now, of course, you could do this yourself as well in the Jenkins script, right? This is possible, but I mean, why would you even want to do that, right? Especially if all this stuff is very specific for each cloud provider. But Spinnaker gives us an abstraction layer of concepts where we don't have to worry about the specifics of these clouds. This enables us to deploy to multiple clouds in the same fashion, by the way. So this is a very important part here of our continuous deployment or the continuous delivery solution, is that automation should be built in, right? So when we actually deploy something, then we want to make sure that we use information from the operational side. So Canary deployments, Canary testing, takes metrics from production and makes decisions while deploying based on those metrics, right? So it's taking information from the operational side into the deployment pipeline. And of course, once it's deployed, we want to make sure that we want to be able to trace back to whatever happened during a Canary release or anything like that when something is actually not working on production. And being able to roll back really easily really has this, it benefits from this operational integration. So now I'm going to be talking about canary birds a lot. I've already mentioned it quite a lot. And we're going to be killing some birds. I don't know if there are any bird lovers here. No bird lovers? Okay, one over there. So I have a special slide for you. I have some canary birds for you, just to appreciate them a bit, because they're looking really cute, right? But we're going to be killing a lot of them. So I hope you don't mind. And okay, so that's over with. So Canary Analysis looks like this, right? It has a stage which has a couple of different analysis results. So you just analyze what's going on in your Canary. and then you get a score for it. And the score is based on the metrics and whether you improved or whether you have the same or whether you actually have a worse result, right? When the score is high enough, then you roll forward. So just to give you an indication, Netflix has a score of at least 95% before it moves forward. And they run their canaries for about like 4 hours at least or something. Sometimes it's days that they're running their canaries, just to make sure that the blast radius is always as small as possible. Right? In this case, we're not going to be doing this for 4 hours, because I suppose you want to see some other interesting stuff today. So we're going to do it for 6 minutes. Of course, the results will be a little bit, less impactful, but I hope it gets the message across. So it looks a bit like this. You have your metrics from your brown release, which is the baseline, and metrics from the blue release, which is the canary. And you can see that in this case, it's a failure because it's only 58% score, right? That's the score. It's not really great. So we're going to be seeing something similar, I hope, right, if everything goes well. Now, aside from that, you can also integrate chaos monkeys. Of course, this tool comes from Netflix, and Netflix are notorious for their chaos monkeys, right? They have the simian army. Is anyone, well, I'm not going to ask, but like, not many people are probably are actually doing chaos testing currently, I think. But it is possible, even if it's just on an acceptance environment or something, you can integrate chaos monkeys right into your pipeline. If someone's unfamiliar with chaos monkeys, it's like having monkeys in production pulling plugs, right? And seeing if everything's still fine. I mean, the last part is sometimes overlooked, where we just implement chaos monkeys and then don't care about them. I've seen that before, which is a bit dangerous. Anyway, so you can do that if you want to. So this is the story about having speed and confidence, right? So Spinnaker really tries to make it possible to ramp up speed and still have safety, right? Which is sometimes contradictory, right? And the way that it does that is making sure you have automated rollbacks, that if things go wrong, that you can easily roll back, that you have deployment windows, chaos monkeys, deployment strategies, and automated Canary Analysis. And that's what we've been talking about, right? But also, it offers some more features, which I'm not going to show, unfortunately, because we don't have enough time. But we have cluster locking. If you have multiple pipelines acting on the same cluster or the same server group, that might give you unintended results, right? So you can lock that cluster so that all other pipelines are held until this first one actually finishes. You can have traffic guards. Now, this stuff can move really fast, right? You can have deployments going on all the time, right? And then there might be some scenario that you haven't thought of that deletes the last server group, right? In some kind of strange combination of strategies. Now, you can have a traffic guard that ensures that whatever you do in your pipelines, you're never going to remove the last server group, because then you have obvious downtime, right? So you can have that easily implemented as well. Manual judgments, we're going to have a manual judgment in our pipeline as well, where we can still say, okay, I want to accept this, or I want to continue, or I don't want to continue. And why is this important? It's kind of the difference between continuous delivery and continuous deployment, right? It's that manual cutover, right? And that's still important. Why? Because it's the gut feeling of humans. A computer doesn't have that, right? A computer can never know about the contextual things that happen in your organization. Well, they might know it's part of it, but not the full picture. It could be that you've just been informed by your colleague that there might be a firewall change somewhere that might impact your deployment, right? Like, you might know that, but a computer might not, right? So still having that manual, that human intervention there is still an important step. And it's just a red button that you can press if you want to continue, right? So it's very cheap. So that's also in there, of course. Conditional pipelines and stage executions allow you to be more dynamic, and of course have more notifications as well. So go fast with safety. That's kind of the motto of Spinnaker here, right? That's when we're going to want to go as fast as possible to production, but still have confidence. So what's coming up for Spinnaker? So Spinnaker is building a CLI for pipeline as code, so you can easily write your pipelines as code. You can already do that currently, but you can also do that through the CLI. Declarative CD, so instead of defining a pipeline that, like we saw an automation example for, you can say, I have an application, I want to deploy that to dev, I want to deploy it to production after dev, and I want to do that in a canary fashion, right? Figure it out for me. And then Spinnaker is going to make sure that, just like with Kubernetes, where you define an end state, that you're also going to reach that end state of your pipeline. which is pretty cool, right? You don't have to write any pipeline code anymore. Also support for artifacts, which is already there. More cloud platforms. So Alibaba Cloud, if anyone knows that, it's actually work underway now to support that. And OpenShift has now stalled a bit, but might be picked up in the future again. Also, more comprehensive provisioning support for Canary stages. You're going to see that we are going to bring up our baseline and our new version, our Canary, next to each other, aside from the production versions, right? We can do that also like in a more declarative way, so that you don't have to worry about that. And then eventually we're going to have to destroy that. That can also be automated. And then there's a whole community behind this, right? There's even conferences about Spinnaker. So it's definitely a growing thing. And more, I mean, all the cloud providers that are kind of the big ones are right now supported, but there's more and more integrations coming. So I think that's enough for the slides, right? Although I do have some interesting slides left for the demo, right? So the demo here is going to be on Azure with Pivotal Cloud Foundry, PAS, we like to call that, running on Azure. We also have PKS, which is Kubernetes, running next to it. Spinnaker is deployed on that Kubernetes, and it's then going to push apps to Cloud Foundry. So it's kind of this joint world, right? I try to get as many different clouds in there as possible, just to make a point. Of course, this could all fail really badly. So we're going to see about that. But the demo has a story behind it. Does anyone know Rick and Morty? Oh, yeah, nice. You know, some conferences I go to is like 1 or 2, but this is amazing. So you might all know this one, right? This is a pretty funny cartoon. And we're going to be working with a green and a blue version. And our green version, our protagonist here, is Pickle Rick. You know, if you've seen the episode, Rick turns himself into a pickle to avoid going to family therapy because he really hates that. But then, you know, things happen and he rolls into the sewer and has to fight against rats and cockroaches. And eventually he comes out victorious. So he's a really strong green version, right? Really predictable, really strong, really stable version, right? Nothing can go wrong with this version. You know, it will always persevere. So this is our green version. Then on the other hand, we have our blue antagonist, right? This is our blue version that doesn't play well, right? I mean, initially it might sound like it's a good idea because it's a genie in a box who exists only to solve the task at hand, right? So that's great, right? But the thing is, if he doesn't succeed in that task, then he grows old, and he doesn't want to grow old. He just wants to disappear again, right? So he gets aggressive because he really wants to solve that task. So he's a really dangerous, chaotic, and unstable blue version. So we probably want to roll that back, right? Right? You get it? Like blue-green deployment kind of thing? You know? Right. So to give you some more feedback about the Me6 thing, you know, I have a whole storyline here. I'm going to go through it really fast. So he was created to solve the task of making this guy golf better. But he can't golf, so that's really hard. So after a while, he starts spawning new versions of himself, right, to help him. But they just can't make it work because this guy can't golf, right? So they all grow old and they all start being aggressive. They start attacking people, right? Because they really want to make sure that this guy can play golf because they all can disappear then. So eventually, this is super dangerous, right? So this is our story. I hope this demo will be much more interesting now that we need to see the story. So for the demo, you can participate as well, right? You can go to this address and see our current version in production. You can even take a picture of the QR code. I don't know if this actually ever works. Has anyone got any success with this? It works? Is it a server error? Are you kidding me? Oh my god. Okay. It works? You have to refresh. Oh my god. Yeah, okay, so this is a live demo, so it might indeed not work. We're going to see about that. So while you're all doing that and trying to get rid of the server errors, right, I'm going to introduce Spinnaker to you as a live demo. So here you can see Spinnaker running on PKS, which is Kubernetes. And it currently has dev and production. So if you look at dev, we have one instance of version 13. Because I've been trying this a lot, right? It's the 13th version. And then on production, there's version 2 currently running. It has 4 instances, right? 4 instances. So if you look at the details, you can actually see the instance IDs and the zone and whether they're up. And they're all saying they're up, so there shouldn't be a problem, I hope. So we can go to the load balancers, and load balancers basically in Cloud Foundry, they're just routes, right? So I can go to the routes for this one. Well, I can click it as well here. Voila. So it gives me this integration as well. And this is my green version, right? It's Pickle Rick. So it's pretty obvious, right, that it's green. OK, so then on production, let's take a look what's happening on production. On production, I've got the green version as well. So everything's fine, you know, no problem at all. Now we're going to change that, right? So I'm going to make a change in my application. Now my application is super sophisticated. We're all at Spring IO, so I've decided to make a very sophisticated Spring IO, a Spring Boot demo, right? So we have a Spring Boot application which has a controller, right? And that controller, it points to a view, Pickle Rick, which is a template, which is an HTML page. Right, so it's super sophisticated, right? I can change this view, and then it will go to me6, right? But we're not just going to do that, because that would be too simple, right? We're going to add some chaos, because me6 are uncontrollable. You know, it's a very dangerous application at that point. So I'm going to change this to me6, and I'm going to add some chaos. Now, what does this chaos do? You might already see it's doing a sleep. So randomly, it's sleeping for 100 milliseconds already. Right? So there is some uncontrollable data, because this is constantly changing, right? Every request that I do, you will have a little bit of that 100 milliseconds. Now, the chaos that I'll add will change this, although it's not predictable, because it always has the random stuff on top of it. There should be a trend, right? And that's what we want to see in our metrics. We want to see a trend that this is actually increased. So just adding like 50 milliseconds, not being too dramatic about this, should already give us a clear impact. So I'm going to change this. So added chaos. Right? So I'm adding chaos, right? I'm doing this the most sophisticated way through GitHub, right? Because I mean, IntelliJ would be overkill, right? We have to wait a little bit, because now my Travis pipeline should kick off at any moment. This could take a while, because it's pulling. But yeah, eventually it's going to do that. So let's take a look at the pipeline itself, right? So my pipeline here has a deploy to dev stage, a deploy to prod stage, which will do a Canary deployment, and clean up the Canary, right? So eventually, clean up the Canary will be automated as well. You won't have to worry about that. But for now, that's still something that I do as a separate pipeline. Now, the deploy to dev, if you take a look at how it's configured, the configuration here, it's basically looking at Travis, because it has integration for Travis. It's looking at the Travis CI master that I'm using, and a job Spinnaker demo, which is, you know, this pipeline, basically. So this could be a Jenkins thing as well. There's actually a lot of things that you can integrate here. So Jenkins, a worker, another pipeline, PubSub, webhook, a cron job, Docker registry. So you could also publish your Docker instance to Docker registry and then have that picked up from there. So that's pretty straightforward. So while our build is going, let's take a look at the next step. So the deployment here, let's take a look at that. So deployment will deploy to the cluster Rick and Morty dev, so in the dev environment, right? And it will do Highlander strategy. Who knows about Highlander strategy? I mean, what could it possibly mean? Anyone has any idea? There can only be one, right? Yeah, so it's going to go in the dev environment, and it's going to take the store, and it's going to cut off all the heads of all the other instances, right? So it's going to make sure that your deployment is the only one alive, right? It sounds very dramatic, but wait until we get to the Canary stage. So, so this is kind of what's going to happen. You can just pretty easily point it to dev and then select the strategy. We can also, of course, take a strategy like a blue-green strategy, which does it a little bit more kindly, right? Or no strategy at all, or your own strategies. Oh yeah, one thing I almost forgot. There's also the artifact that we're getting from S3. So I'm just going to look at my S3 repository or bucket, and I'm going to pick up whatever's been built there, right? And Travis tells me which one to take. So Travis has now finished, right? It's green, so that part at least works. And this one is now deploying. And if we now look at our infrastructure, and we get rid of the prod thing, you see that in dev, now you have, over here, now you have version 14 being spun up. So version 14 is now currently disabled because it's still starting. Version 13 is still running. Now, if we refresh, and you can also participate in this. Hold on, let me get the load balancer first. So the dev one, right? Then now you see my blue version, right? And you know it's Me6, right? Pretty obvious. So this is the blue version, and it might be that we still have a little bit of a green version. No, I don't think so, because the Highlander kicked in. You know, it just destroys the older version. So as you can see here, version 13 is now. Is that working? You know, it's now disabled, right? So that's working. That's good. You know, part of the story already makes sense. So we are disabling the cluster. Let me just zoom out a little bit. There we go. And then, like, we are deploying first, then we're disabling the old cluster, and we are shrinking the old cluster eventually, right? So that's basically underway. What's going to happen next is that it's going to deploy to production right away. So we validated it in dev. It's fine. Just go ahead and deploy. Normally, you would have some more stages in there, right? So this configuration here, it just looks at the previous pipeline, whether it was successful. And it was successful, so it's going to kick it off. And then it's going to deploy a baseline and deploy a canary. Now, why do we deploy a baseline, you might ask, right? Because you already have production environments running the older version, right? It's because we're going to be measuring these two things next to each other. And when we are measuring metrics, like system metrics, then they could really be impacted by a startup, right? Or even if you're having your instances running for a long time, there might be memory leaks or something, right? So if you're going to be looking at memory consumption, then that might just give you a completely different view. So just having 2 new instances start up, actually we're spinning up 4 instances in total, 2 baselines and 2 canaries, so we can actually have some load there. That gives you this shared, this common baseline that you can work from. So the baseline will just clone it from production, right? That's basically the current version of production, we're cloning it. And then the canary version, that's actually coming from, that's actually a Highlander again, coming from the same source as dev. So that's definitely the latest version, right? So that's basically what we want to start with. So if you look at the pipeline, it's doing it, right? It's deploying it. If you look at the infrastructure, if we just look at production only, and then we refresh, all of a sudden we've got baseline and canary spinning up, right? So these are 2 extra instances that are going to be spun up next to the existing cluster. And I don't have any sophisticated load balancing currently set up. It just means that if I look at load balancers, right, and I refresh, right, at some point, it's going to show here that it's not just version 2, if I also show instances, my 4 instances of version 2 of production, that's going to receive traffic, but also the baseline and also the canary, right? So if you all go to the same page, right, if you all start refreshing, you should be seeing the canary also being fed to you. Of course, this is not something, as you can see here, voila. So we have in total 8 instances. Now, I just want to make sure this works, so I'm going to start doing some extra load, right? Because, you know, sometimes I don't have enough load. So hold on, which I can see the repos. So, okay. So I'm generating some load here just to make sure my application has enough metrics to deal with. And you can see here already that Me6 and pickle rigs are being returned together, right? So if you start refreshing your page, you will see that you'll have, at some point, you'll have Me6 and at some point you'll have pickle rig. And that's actually the canary playing together with the current production version, right? So if I refresh here, some points, there we go, you have the canary. So we're now feeding information into the canary. And if I look at my Datadog, it's now receiving metrics from my baseline and from my canary, right? And as you can see here, I have 2 metrics that I care about, rendering time average and rendering time maximum. So I really want to care about how fast does it respond to me, right? Because that's the chaos that we introduced. And you can see here that the baseline has is actually higher. That's a bit strange, but it's still starting. I hope this is going to, you know, fix itself. We'll see. That's why we do canary testing, right? So if I look at my canary here, currently it's already running, right? Like, oh, let me go here, sorry. My canary here is running, And you can see that, well, it's actually not doing much right now. Why? Because my Canary config says that my warm-up period is 1 minute. We just want to get rid of these start spikes, in CPU and RAM. We don't want to care about that. My interval is 1 minute, and I already failed, apparently, which is really fast. My interval is 1 minute, where it kind of had 1 minute time to look at the metrics, and then it's going to do an analysis, right? And then it's going to have a step of 10, so that means every 10 seconds you're going to have metrics. Right? So what does it actually measure? Let's see. So it's looking at rendering time average, CPU. Well, let's first look at system metrics. So system metrics, CPU usage of the system and also of the process. JVM memory used and logback events. Right? So if there's any errors in the logs. So all this information is gathered. And then for Rick and Morty, on this side, we look at business metrics. Well, these are not really business metrics, but they could be, where you have rendering time average and rendering time maximum. So let's take a look here. I hope that everything is working fine. Yeah, should be fine. So here you can see we actually did a Canary analysis, and we looked at the results that we got. So let's take a look here. Voila. And here, if I have to zoom out a bit, sorry for the people in the back. So here you can see that memory consumption is fine. The deviation is like 1.4%, which is not much. Logback events, no errors in both cases. CPU usage is about 11%, but it gives it more time. It's still a pass. And then we see that the average rendering time has increased with 120%. As you can see, the blue line is Canary. It's a lot higher now, right? So the trend that we measured is that the Canary is dangerous and we should roll back. And then the rendering time maximum here, as you can see, is a lot higher. And also thanks to you refreshing, of course, and my random load. And then we've got system CPU usage, which is also still fine. So here you see that we have a dangerous version because these metrics don't actually show us a good story, right? So we have to roll back. And the thing that actually is happening right now, has happened, I'm sorry, it's too fast, is actually cleaning up the Canary. So it's destroying the baseline and destroying the Canary, right? Which is pretty straightforward. So if you look at the infrastructure, it's all gone. Like nothing happened. And if you go to the production version here, and you refresh, it's back to the green version. So this is kind of how Canary Analysis can help in automatically figuring out whether your application is working, not by doing end-to-end tests or chain testing on an acceptance environment where everything is being held back and you lose speed, but actually going to production and testing in production with real data and real users. Of course, while making sure that you have a blast radius as small as possible and that you can easily roll back if things do go wrong. And so that's kind of the idea of automated Canary Analysis. So if we go back to the slides, so speed and confidence, we've been talking about this at the start, right? This is kind of what Spinnaker is about. It tries to get you, give you more speed in your delivery while increasing your confidence, right? So that's kind of a unique selling point, I suppose. If you want to know more about Spinnaker, specifically, you have a free ebook online. If you just go to spinnaker.io, you can download this book. It's about 75 pages. It's really simple, really fast to read. And it's going in much more detail about all these things I talked about today. Right? So it's definitely something I would advise to read. So I think that's it. That's the wrap, I think. The slides will be on SpeakerDeck. If you just go to my name, it's going to be there. On Twitter, you can always send me messages or questions. You can reach the Spinnaker team themselves on Slack. Right? So you can just go to spinnakerteam.slack.com, and the people from Netflix, from Google, from Pivotal are all there and helping people out. On Stack Overflow, you can just ask questions on the Spinnaker tag. And of course, all this information is available on Spinnaker.io as well. So if there's any questions, please ask, but thanks already for your attention. Question?
Hi. Can you show a little bit how you configure Spinnaker to connect with Datadog? So how it's the right. Canary analysis, how do you do it actually?
All right. So the Canary analysis right now, so basically what I have to do is I have my awesome Spring Boot application. It integrates with Micrometer or Micrometer, I don't know which one. And that would then expose these metrics, right? However, it doesn't know where to send them, right, for now. So I have to have some environment variables that tell them where to send it, right? So I think, if I'm not mistaken, here I have metrics exported from Micrometer, right, to Datadog, specifically to Datadog. And my API key, application key, are basically exposed on Datadog itself. So you can get it over there. And then I put them here in my deployment. Well, let me take this one here. Let's say my deploy Canary, right? If I take a look at it, there are some environment variables, and I hope you, yeah, okay. I will change these keys, of course, because they're now pretty visible. Anyway, so here they are, you know, feel free to use them. But that's how I expose it, right? And then it picks it up from the environment, it injects them, and it just starts sending metrics, which is pretty straightforward. Right, it also works a similar way for all the other ones that Micrometer supports. Any other questions? All right, thanks everyone.